Okay, so uh, we are on in the module 2, module 1, and I guess my voice is reaching to all of you. Just a second. Yes. So in module 1, we have started with introduction to additive manufacturing, and then we have discussed about uh, in the previous class we could see different types of printers, and no, not different types of printer, few printers we could see. Then we have covered general introduction and different terminologies that are used for additive manufacturing. Then uh, the steps involved in additive manufacturing process. Okay, so I hope those who have attended this lecture, the first lecture, they might be aware about the basic steps or the main steps in any of the additive manufacturing process. Okay, so just for revision, uh, first step is preparation of your CAD model in your solid modeling software. Then you need to convert that solid model into a STL file. Then you need to transfer that STL file on additive manufacturing machine. Then you have to set a machine related parameter, and then finally you have to in step 5 you have to either click on the build button or print button, whatever button is available on the printer available to you. Then you have to remove the part which has been fabricated depending upon the CAD model. Okay, then post processing and the application part of the component. Okay, so these were the things that were discussed in the previous class, and in today's class we will start new topic, that is classification of additive manufacturing process. Okay, so yeah, so there was one more small topic, that is before we go into the classification of additive manufacturing processes. So because there are two groups, like second year student as well as final year student. So I guess the students from other department like civil, electrical, and EC might not be aware about CNC machining. So deliberately I have kept one slide only, so that there is no little discussion about CNC machining and a comparative study on additive manufacturing and CNC machining. Okay, so those who are not aware, I will tell them that what is CNC. CNC stands for computer numerical control. Okay, and there we are using a computer to control the machining processes. Okay, so either it is CNC or conventional machining processes. How this AM process is different from your these processes like conventional machining or CNC machining. Okay, so uh, I have made it short, this topic, because I will not be explaining much on this PPT, because we have to cover the classification uh, in today's itself. Okay, so the first first you can say first important thing, or the advantage of additive manufacturing processes are that these processes are very flexible and very capable. You need to only create the 3D model of the component which you want to produce, and you can directly print it. You can see it is as simple as like printing uh, your when you go for printout, you just go with the text file and you get the printout from any shop. Okay, so maybe in future you will get similar kind of similar kind of shops will be available in future, where you can go and you will go with a 3D drawing of your component or the part which you want to buy, or you want to you know uh, uh, use for the application wherever you want to use. You will go to the shop, a 3D printer shop, and maybe he will give you a printout within maybe within half an hour, or maybe less than that. Yeah, but currently it is not possible. But still, these AM processes are very flexible as compared to your CNC machining processes or conventional machining processes. Okay. There are certain limitations to again related to your AM processes, because these additive manufacturing processes works especially for the specialized materials. Okay, we cannot use one printer, as I have discussed in the previous lecture. We cannot use any printer for any material. The material that can be printed on any printer that is pre-specified, you can use that type of material only. In some cases, you will find limited accuracy when you are producing product using your additive manufacturing processes. So why these limited accuracy issues there? What are the limitations that we will be discussing in module 1 itself? Okay. More about conventional machining or CNC machining. These processes are subtractive. Subtractive. What is the meaning of subtractive? So let us try to understand what do we mean by subtractive processes. Okay. So I hope you are aware about at least about additive meaning of additive processes. Additive means we are adding material, or we are adding a layer of material on another layer of material. But in the case of subtractive processes or the machining processes, what we are doing, we are having an initial metal block, maybe some arbitrary shape I am drawing. We are having some metal block, and we are machining it. It means we are subtracting material from it in order to convert into a desired shape. Like suppose we want to convert it into a cylindrical component. Okay, so what we have to do, we have to subtract it, or we have to remove material from this metal block. Okay, so that is why these processes are called as subtractive processes. Moreover, since these processes are well established, like we can go from conventional machining to you can say you can get a very fine or accurate surfaces. You can say in talking in terms of scale, you can get in you can get surface quality in the range of micrometer. But with additive manufacturing processes, it is quite limited, because we are depositing material layer upon layer. So that much surface quality is not possible, and that is why the AM component or the part produced by AM processes are not that much accurate, or maybe they require secondary processes in order to make the surface smooth. Okay, so CNC machining is more accurate, and it can be you can say you can use multiple material on a CNC machine, because it is not dependent on that only one kind of material will be machined on a particular CNC machine. Okay, but in the case of additive manufacturing or 3D printer, we have this limitation that we cannot print any material on any machine. We have to design the additive manufacturing machine depending upon your material requirement or the material to be printed, right? So CNC machining is capable of using many common manufacturing material. In most of the material, you can machine these material using your CNC machine. Moreover, there are some more limitation related to your CNC machining, that these CNC machining are not automated. You have to write program. Those who are aware about NC programming, like final year mechanical engineering student, I expect that at least they must be aware that what kind of programming is needed to operate on CNC machine, or to complete a process a part on CNC machine. And for understanding that programming, we require a highly skilled technician. But in the case of your AM processes, I guess like from the demonstration which I gave in the lecture 1, you can easily understand that even a layman to whom you will make to understand that how to use this 3D printer, he will be able to produce the product using your AM process. So in that term, you can say a CNC machine has limitation that they require highly skilled technician, and there are more other limitations with CNC machining, that you cannot create all types of part. Okay, so like for example, you cannot create hollow parts. You cannot have severally undercut features. Like if you want to have a number of features that have undercut on it, you cannot machine these parts on CNC machine. Okay, so for that those kind of product you will prefer, if you are having the 3D printer related to that particular material, you can easily print your part using your AM machine. Yeah. So this is a small discussion. I wanted to make it part of your curriculum, because it is already mentioned as a in under your module 1. So we can elaborate this topic with different books, like what are the other advantages of additive manufacturing processes as compared to your CNC machine or your conventional machining processes, or vice versa. Well, there are some good things with CNC machines too. Okay, but yes, both technologies have their different advantages. Okay, so you can explore more on Google. Yeah. So coming to the today's main topic, that is the classification of additive manufacturing processes. So there are various ways based on which these AM processes can be classified. So these are basically in today's classification, I will be discussing the classification which is based on the based on the shape of material, that is what kind of material is being used during the printing of your or printing of your product, or production of your component using your AM machine. So there are three kinds of input material, like material may be initial material may be in the liquid form, solid form, or powder based. Like in the first lecture, somebody asked whether we can use slurry, or somebody said what kind of material will be there, what will be the properties. Okay, so these things we will be discussing. There are basically three types of material that are used in AM processes. First one is liquid based, then second one solid based, then third one your powder based materials. Okay, so depending upon the starting material, we have classified these AM processes. Okay, so yeah, so as I have told, during liquid based AM processes, we have starting material as a your starting material is a liquid, and there are a number of techniques which are available in this type of category. For example, stereolithography, solid ground curing, then droplet deposition manufacturing. So stereolithography, coming to, let us take the first case, that is the stereolithography. So it is a additive manufacturing process for fabricating a solid plastic part out of a photosensitive liquid polymer using a directed laser beam to solidify the polymer. So here what kind of liquid polymer we are having? It is photosensitive liquid polymer. Okay, the kind of material that we are using, it is photosensitive. It means as soon as that laser strikes on the surface of that particular liquid, it will get solidified. Okay, so using that principle, we print the desired component in stereolithography technique, and we add one layer of yes. So part fabrication is accomplished as a series of layers, and each layer is added onto the previous layer to gradually build the 3D geometry. Okay. Yeah. So yeah. Yes. So let us try to understand using the diagram what is this technique, how this stereolithography techniques works. So here we are having a container, and in container you are having a liquid polymer. Okay, liquid polymer that is having photosensitive in nature. Okay, so if your your laser beam strikes on this polymer, what will happen? It will get solidified. Okay, so here we are having, this is the part base, you can say base of your part that needs to be produced. This is the platform on which your part base has been placed. This is your laser source, and from which your some laser is coming. Okay, this is your xy plane, and your laser can move in z direction. Okay, so yes, so here we can see we are having a liquid container, and on which we are having a platform. Okay, then you can see here there is some liquid over this part base, and that has been printed actually due to the solidification of polymer. Okay, so even though when this part base is not there, what you have to do, your platform will having liquid polymer above this platform. Okay, so wherever your laser will move, this liquid will get solidified, and you can say uh, first layer of your material has been printed due to the solidification of liquid polymer. Okay, so and as soon as this laser moves on this whole surface, your whole layer is gets solidified, and you lower this whole platform by a distance delta z. Okay. Okay, I will explain one process, because I have to, yeah. So, by a step delta z, if you lower this in uh, your platform, what will happen? Again, fresh liquid will come over this previously printed layer, and again you will move your laser. Okay, so again that second layer gets solidified, and you have to again lower this platform by the distance, that is delta z. Again, this delta z is your layer height. Okay, so this way, if you continue, and if you control the movement of laser depending upon the your slice data, that is slice data which you have got from your STL file. Okay, so if you control the movement of your laser depending upon your slice data, the structure or the part as per your desired shape has been created. Okay, so in the figure you can see your starting of your process, and in figure 2 you can see there are several layers of your polymer that has been solidified, and you can see the final part or the final geometry by using your stereolithography technique. Okay, so this way the stereolithography techniques works, and we will be discussing about stereolithography in detail in our coming module, because our whole syllabus is designed for the discussion on these different types of your additive manufacturing processes. Okay, so we will be discussing in more detail what kind of materials can be used, how do we control the laser source, how do we decide the path of your laser source, how much time we need to imping your laser on your liquid polymer. That we will be discussing in coming module, or the next upcoming modules of your this subject. Okay, yeah. So this kind of product you get finally uh, from your stereolithography technique. This kind of component are produced. This is the component that has been printed on a platform of your machine. So this is the platform on which your this component has been printed from the liquid polymer by layer solidification of the liquid polymer. Okay, so these kind of product you can get from your stereolithography. Okay, then we have I will move a little bit fast because I have to tell about classification of all the processes. Okay, so solid ground curing, it is the second process in your liquid based additive manufacturing processes. Like stereolithography, solid ground curing works by curing a photosensitive polymer layer by layer to create a solid model based on CAD geometric data, right? So here also what we are doing, we are curing some liquid polymer. Okay, it is, this polymer is again photosensitive. Okay, but the technique is different. So yeah, so let me explain through the diagram. So here we are having, you can say we need to prepare the mask corresponding to the geometry required. Okay, so first step, you will prepare mask and you will apply uh, uh, liquid polymer layer. Okay, so you need to uh, you are having a mask here, and once you have a UV lamp over it. Okay, so as soon as this UV lamp glow, the UV rays pass through this mask. Okay, so wherever you have transparent layer, this UV light will pass through it, and your material will get solidified. Okay, so this way you can create number of layers as much as you require by using these mask. Okay, and you get your final product in the desired shape, or whatever shape you have created based on the mask prepared. Okay, so this way, in this type of processes, the only limitation is that you require milling for creating the flat surfaces. In the later stage, maybe maybe due to the ununiform intensity of light, the part surface may not be uniform, so you will require milling for flatness. Okay, so this is about solid ground curing. Then another type of process in liquid based material or liquid based additive manufacturing processes is your droplet deposition manufacturing. So in droplet deposition manufacturing, yes, yes. No, yeah, from my side it is moving because I am cross checking on my secondary screen. Okay, maybe there is some issue with your network. Other student, you can see na droplet deposition manufacturing, because I am cross checking, I am having secondary. Yeah. Okay, so those who are having this issue, maybe there is network issue. Yeah. So in the case of droplet deposition manufacturing, the starting material is melted, and small droplets are shot by a nozzle onto previously formed layer. Okay, so here what we are using droplet, and we are uh, 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 we are shooting these small droplet by a nozzle. Okay, so here again, what we are doing, yes, look here, what we are doing, we are building the material, and the material is being deposited in the shape of your droplets, and you get your final product depending upon the amount of material deposited on each layer. Okay, so this way, in the case of droplet deposition manufacturing, again you have material in the form of your liquid shape. Okay, the material is in the form of liquid, right? So this is about three kind of processes in liquid based additive manufacturing processes. Then we have second type of processes, that is solid based additive manufacturing process. So as the name indicate, in solid based additive manufacturing processes, again your starting material is solid. Okay, so you it may be in the form of wires, or it may be in the form of seeds, but the material is in the form of solid. Okay, so solid based IM processes, these are basically two types. The major processes are two: laminated object manufacturing and fused deposition modeling. Right. Yeah. Again, laminated object manufacturing. So in laminated object manufacturing, what we have, we we uh, we have solid physical model made by stacking layers of sheet stock. Each, yeah, yeah, 1.2 and 1.3. Yes, yeah, 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 yeah. This one, yeah, ultraviolet. Okay, yeah, yes. I guess we can take questions in last 5 minutes, because I have to cover quickly. You please note down the question. Okay, I will take you. Okay, yeah. So yeah. So we were here. Yes. Laminated object manufacturing. We will get time. Okay, for questions. Yeah. So solid, under laminated object manufacturing, we have solid physical model made by stacking layers of sheet stock, each on outline of the cross-sectional shape of a CAD model that is sliced into layer. Okay. So here your static sheet stock includes paper, plastic, cellulose, metals, or fiber reinforced material. The material is the seat is usually supplied with adhesive backing, or as rolls that are spooled between two rails. After cutting, or excess material in the layer remains in place to support the part during building. Okay, so let us try to see here. You can see you have a laser source, and you have a seat stock. This seat stock may be like this in the form of your supply roll. So here what you will do, you will on this particular your part production platform, what you will have, you will, as soon as your roll is here, your laser beam will strike on this surface, and your your seat or your layer get, get adhesed with your previous layer. It get, you can say, uh, by partial melting or by some other process, because due to laser striking, obviously there should be some temperature rise, and due to this the adhesion takes place between these two layers. And as soon as the this complete adhesion takes place on the layer, you take the fresh material on this particular layer, and you lower the platform by the height required, that is the material thickness. Okay, so this way you laminate, in fact you laminate your seats layer by layer, in order to get your final product. Okay, yeah, this process is there actually, that's why I have discussed, but it is not much used in actual additive manufacturing processes. Okay, this process was one of the, initial level work that was done in the case of your additive manufacturing process, that is sheet lamination. Yeah, then we have most commonly used process among your all AM processes, that is the fused deposition modeling. So in this process, a long filament of wax or polymer is extruded onto existing part layer surface from a workhead to complete each new layer. The workhead is controlled in the XY plane during each layer and then moves up by a distance equal to one layer in the gen direction. Extrudate is solidified and cold welded to the cooler part surface in about 0.1 second or even less than that. Part is fabricated from the base up and using a layer by layer process. Okay, so in the case of fuse deposition modeling, yeah. So let me yeah let me open some, because I have not put diagram for fuse deposition modeling. Yeah, yeah. For more clarity, I have taken this figure. Yeah, just a second. So here, this is, you can say, example of fuse deposition modeling. So here your material is being extruded through the nozzle, and it is getting deposited layer by layer depending upon the slice data that you are having with you from your STL file. Okay, so this is how your fuse deposition modeling works. Then we have third category, that is powder based additive manufacturing processes. Okay, so here also, as the name indicate, your starting material is in the form of powder. And in powder based additive manufacturing processes, there are two kind of processes that has been developed. That is, first one is your selective laser sintering, and second one is your three-dimensional printing, which is also not also known as 3D printing. Okay, so in powder based additive manufacturing process, the first process, that is selective laser sintering. So here what we are doing, by moving a laser beam that centers heat fusible powders in areas corresponding to your CAD geometry, one layer at a time, to build the solid part. Okay, so here what we are having, this process is more or less same like previous process, but in here we are having, instead of liquid, we are having your uh, metal powder, or the material powder, which is, spread over your build platform. Okay, so after each layer is completed, a new layer of loose powder is spread over the surface. Okay, so after each layer, you are spreading again fresh powder on the surface of your previously solidified layer. Layer by layer, the powder are gradually bonded by the laser beam onto a solid mass that form the 3D part geometry. In areas not centered, the powder are loose and can be poured out of your completed part. So this is the, you can say, that unused powder can be taken out because it is not centered, right? So it is taken away, and it can be reused during your selective laser centering process. Yeah. Then we have last process to discuss, that is three-dimensional printing. So in this three-dimensional printing, which is also known as 3DP, the part is built layer by layer using a inkjet printer to eject adhesive bonding material onto successive layer of powders. The binder is deposited in areas corresponding to the cross section of part as determined by the slicing the CAD geometry model into layer. The binder holds the powder together to form the solid part, while the unbonded powder remain loose to be removed layer. Okay, so here also you are printing the part using a inkjet printer, and you are ejecting a adhesive to make bond between these two successive layer of powder. Okay, so in the previous, like selective laser sintering, we were not using adhesive, we were melting your powder particles by using your your laser source. But here we are using uh, a adhesive with, which comes out of your a inkjet printer. Okay. To further strengthen the part, a sintering step may be applied to bond the individual powder. Okay, so further sintering may be done, maybe partial heating, or maybe some other processes in order to provide the proper strength to, to your part produced by your 3DP or three-dimensional printing process. So here you can see loose powder and how this layer by layer deposition is taking place in the case of your three-dimensional printing. Okay, so, yeah, so that's all from my side.